Okay, in this college algebra video lecture, I want to talk about some basic graphing concepts. Now, if we're going to graph, we need to be able to plot coordinates or plot points. So let's make sure that we all know how to plot points. Now, I've got a graph pulled up that we can take a quick look at. So if you look over here, you'll see the point 0, 0. Okay, that's the origin. Remember, your graph has an x-axis and a y-axis. The x-axis is horizontal, the y-axis is vertical. The first number represents the x value, the second number the y value. So the point 0, 0 would mean you don't go anywhere on the x-axis and you don't go anywhere on the y-axis. So you're going to be right here where they intersect. So that's the point 0, 0. Now if you want to plot other points, let's say you want to plot the point 0, negative 5. Okay, well, to plot the point 0, negative 5, then what you have to do is you have to start at the origin. Since x is 0, you don't go right or left, but you go down 5 units. So 1, 2, 3, 4, 5. So there's the point 0, negative 5. Then let's say you want to graph negative 3, 0. Well, there you have to go left 3, 1, 2, 3. And then since y is 0, you don't go up or down. So you're right there, negative 3, 0. Now if you want to go, let's say you want to graph negative 3, 2. Well, then you got to go 3 to the left, just like I just did, but y is 2, so you got to go up 2. And that's how you get the point negative 3, 2. And then let's say you want to go 3, 4. Alright, so x is 3, so we go over 1, 2, 3, and then we go up 1, 2, 3, 4, and we get the point 3, 4. And then the last point I have here is negative 2, negative 5. So to get to that point, we go over 1, 2 to the left, and then go down 1, 2, 3, 4, 5, and we get negative 2, 5. And so that's basically how you graph or plot points. Now this quadrant over here where x and y is both positive is quadrant 1, and it goes counterclockwise. Over here is quadrant 2, this is where x is negative and y is positive. Down here is quadrant 3, this is where both x and y are negative. And over here is quadrant 4, this is where x is positive but y is negative. So that's the basics of the Cartesian coordinate system. The next thing I want to discuss is the midpoint formula. This formula can tell you the midpoint between any 2 points in the Cartesian coordinate system. Basically what you do is, if you're given 2 points and you want to find the midpoint, you add the 2 x values and divide by 2, and that'll give you the x value of the midpoint. You add the 2 y values and divide by 2, and that'll give you the y value of the midpoint. Now here I'm given 2 values. These are the 2 endpoints, and I want to find the midpoint. Well, if you'll notice, the x values are 3 and negative 1. So over here I'm going to add 3 to negative 1, which is going to give me 2. And then I'm going to take 2 and divide it by 2, and I'm going to get 1. So the x value of the midpoint is 1. Then I'm going to take negative 2 plus 9, and I'm going to get negative 2 plus 9 here, which is going to be 7. And then 7 divided by 2 is 7 halves, or 3 1/2. And we can see that if we take a look at the graph. You'll notice here on the graph I've actually identified the 2 points that we're finding the midpoint of, and this is so pretend like there's a line connecting these two, and we want the point that's exactly in the middle, somewhere in here. Well, we've come up with that point, and we've determined that the point is 1 7 halves. Okay, and so there it is. Of course, this is saying 1 and 3.5, but that's the same thing, 1 and 7 halves. So that's how you find the midpoint of the segment that connects 2 points. Now let's look at this problem from a little different vantage point now. Let's say that we're given an endpoint. So this is an endpoint, and this is the midpoint. Okay, well, this works a little bit different. Since we know the midpoint is 3, negative 1, and we know the midpoint formula up here is just the sum of the x values divided by 2 and the sum of the y values divided by 2, then I can take this endpoint here, negative 1, 5, and I know the other endpoint, let's call it x2, y2. Well, you know if you add the two x values together, you should get the midpoint, or the x value of the midpoint. So I'm going to say negative 1 plus x2 over 2, that's going to have to equal 3. And then if I add the two y values together, 5 plus y2, that should equal the y value of the midpoint, which is negative 1. So 5 plus y2 over 2, that should equal the negative 1. Now I can solve these two separately. The first one, I knew that negative 1 plus x2 over 2 has to equal 3. So then I'm going to multiply both sides by 2 and get negative 1 plus x2 equals 6. And then just add 1 to both sides and I get x2 equals 7. And then I take for the y value, I take 5 plus y2 over 2, and that has to equal negative 1. And then if I multiply both sides of this equation by 2 to cancel the 2, I get 5 plus y2 equals negative 2. And then when I solve for y2 from that equation, I get negative 7. So that tells me that the endpoint is 7, negative 7. And if you look here, here's the 2 points that I was given. This was an endpoint, and this was the midpoint. So look what happens if I put in the point I got for the other endpoint. Okay, it appears that that is the other endpoint, because it looks like the distance between these 2 points and the distance between these 2 points is the same. Well, it turns out that if you, I don't know if you saw that, but anyway, I had to click off of something there. My phone rang, and I'm sorry about that, but let me go ahead and continue with this video. I want to talk now about the Pythagorean theorem, and in this theorem we have, if you have a right triangle, now down here I've got a picture of a right triangle, and basically what we mean by right triangle is you have a right angle in the triangle. And if you have a right triangle, and let's say you have two legs here, let's say this leg is A and this leg is B, and the hypotenuse we generally call C or X. So basically in a right triangle you always have this relationship. If you sum the squares of the legs, you'll get the square of the hypotenuse. So if I give you a right triangle with legs 8 and 5 and ask you for the hypotenuse, you can use this formula. All you have to do is, let's just turn it around and say c squared, since that's what we're looking for, must equal the square root of 5 squared plus a squared. I'm sorry, I said that wrong. Technically, c squared equals 5 squared plus 8 squared. And then c is equal to the square root of 5 squared plus 8 squared. Okay, and that's actually 89, and so c would be the square root of 89, which is approximately 9.4. Okay, so on the next question it says find the distance from third base to first base on a baseball field if the bases are 90 feet apart. Okay, so this would be first base and this would be third base on a baseball field, assuming this is home plate. Okay, so if you wanted to throw from first to third base, the question is basically how far would the throw be. So let's say what you want to find, if you take a look at, let me see if I can draw this for you, get rid of that, do a better job here of drawing this. Basically what you're looking at is, this is one side of your right triangle, and then you have this is the other side. I'll get it here in a minute. This is the other side of the right triangle, and basically what you want to do is find the hypotenuse of that right triangle. So we know that the distance from home to first is 90. We know the distance from third to home is 90. So these are just the legs of your right triangle. And so what we want to find is this x here. And so we know that x squared, I used c here. Let's just change this to c. Okay, so you can call it c or you can call it x. So we know from up here, from the Pythagorean theorem, we know that c squared equals 90 squared plus 90 squared. So c would actually be the square root of 90 squared plus 90 squared. You can see I corrected that typo there. And then 90 squared plus 90 squared is actually 16,200. So c would be the square root of 16,200, which is about 127.3 feet. So about 127 feet and a few inches. You know, it's a little over a quarter of a foot, so that'd be about 3 inches, a little over 3 inches. So that's the distance from first base to third base on a standard baseball field. Okay, I'm going to finish this lecture with some distance problems and a couple of other examples. This is the distance formula. This will find the distance between any two given points. So let's say you have x1, y1 is -2, 4, x2, y2 is 5, -1, and you want to find the distance between the 2 points. Well, basically, you just take the difference of the x values, 5 minus -2, which would actually be 5 plus 2, and then you square it, and then you take the difference of the y values, -1 minus 4, which would be -5, and you square that, and then you're going to take the square root of those two sums. So you're going to take the square root of 49 plus 25, which is the square root of 74, and if you need an approximation, you can plug it in your calculator and get that that's about 8.6 units. Now, on both of these next two examples, I actually used the distance formula, so I'm not going to rehash the calculations, but let me just show you how to solve them. If you're given 3 points and you want to show that they're in a straight line, basically what you have to show is that if you add the distance between two of the points, they equal the distance to the third set of points. So what I'm going to do is I'm going to find the distance from A to B. And so let's just pretend like this is point A. It doesn't really matter. It doesn't really look like this on the graph, but let's pretend like that's point A. So the distance from A to B is about 4.24. So that would be, you know, say the distance from here, A to B, would be that. And then let's say the distance from B to C is a little less. It's 3.61. Okay. Well, the distance from A to C, when I applied the distance formula, I got 7.81, or square root of 61. And when you add the distance from A to B to the distance from B to C, those are the two shorter distances, you actually get 7.85, which is not the same as 7.81. So there's no way, since this distance plus this distance does not equal the total distance from A to C, there's no way that they can lie on the same line. Now on the next question, I'm trying to show if these points give a right triangle. Well, for these points to represent sides of a right, or vertices of a right triangle, the distances must satisfy the Pythagorean theorem. So what I did is I found the distance from A to B to be 10 square root of 2, the distance from B to C to be 10 square root of 2, and the distance from A to C to be 20. And then I just checked the Pythagorean theorem. I went ahead and did the two shorter sides squared, and if you square these two, you're going to get 200 for each of them, and then you add them together, you get 400. And then I took the third side, I squared it, and I also got 400. So since A squared plus B squared equals C squared, yes, they do represent the sides of a right triangle. And you can plot these points on a graph and you can see it, but there's no way to really know for these last two questions if the answer is yes or no unless you check these distances and see if they satisfy the appropriate formulas. Okay, we'll talk about graphing on the next video.